In the first packet, we found silica gel beads. These are often placed in shoeboxes to absorb excess moisture. The bead needs to be taped to the phone camera. I chose the clearest and roundest bead. The smaller the bead, the greater the magnification. Let's see what happens. Oh, wow! It really works! I remember the same principle was used in Leeuwenhoek's microscope, but the lens was a glass bead instead of a silicone one. Maybe I don't need a microscope after all. After many attempts, this is the best image I could capture with this makeshift microscope. To be fair, I have to say that the view with the naked eye is better than what I captured on camera. Let's move on to the kid's microscope. I had a similar microscope when I was a child. My dad gave it to me for my birthday. I was incredibly curious to look through it, but honestly, I couldn't figure out what I was seeing back then. On the other hand, I spent my entire childhood trying to solve this mystery, and eventually I became a microbiologist, so maybe it wasn't that bad after all. Let's get back to the technical specifications of the kid's microscope. It has 3 lenses that magnify 5 times, 10 times, and 20 times. The eyepiece magnifies 6 times, so the maximum magnification is 6 times 20, which is 120 times. You need to catch the light with a mirror. The stage doesn't move, so you have to move the specimen by hand. The focus adjustment screw is a bit jerky on this particular microscope. Let's see how a bee's leg looks under it. Since it's not possible to attach a special camera to the kid's microscope, this photo was also taken with a phone. And again, the result is not as good as what you see with the naked eye. But on the other hand, I wanted to show you what you get, so here's the honest result. Next, we have a stereo microscope. It's usually used for examining minerals or insects, basically, any 3-dimensional opaque samples, but we'll also try it with a bee to see what happens. A stereo microscope doesn't magnify very much. It's more like a magnifying glass with a light. The lens can either not magnify at all or magnify 3 times. The eyepiece on this model magnifies 10 times, so the total magnification ranges up to 30 times. You can illuminate the sample from below if it's transparent or from above if it's opaque. The sample can be held in place with stage clips, which is very convenient. The bee's leg magnified quite nicely. But let's see how it magnifies a 3-dimensional sample, the purpose it was designed for. Let's take a beautiful peacock feather as an example. Splendid. This is a porcupine quill. This is a mineral agate. And this is a sea urchin shell, a sand dollar. It's time to examine the compound student microscope. It has 4 lenses with magnifications of 4, 10, 40, and 100 times. The eyepiece magnification here is 16 times. Therefore, the maximum magnification this microscope can achieve is 1600 times. This microscope has a special clip that holds the slide with the sample. There are 2 knobs that allow you to move the microscope stage forward and backward, as well as left and right. It also has bottom lighting with a condenser that focuses the light in the right direction. In addition to the coarse adjustment knob, this microscope also has a fine adjustment knob to help find focus at higher magnifications. And here is the result with the bee's leg. And finally, the professional microscope. It also has 4 lenses with the same magnifications, 4, 10, 40, and 100 times. This model has a special tube for attaching a video camera, so you don't have to switch the eyepiece to the camera whenever you want to take a photo or video. The eyepieces magnify 25 times. This gives a total magnification of up to 2500 times. The microscope stage is also equipped with a clip and can be moved using knobs. It has bottom lighting with a condenser, and the brightness of the lamp can be adjusted. It also features both coarse and fine adjustment knobs. Let's see if it's worth the money. And here is the bee's leg. Well, it's very good, but the student microscope's result wasn't much worse. Even the binocular microscope gave a decent result. We need something more challenging. I suggest we see how these microscopes handle bacteria. For this challenge, I decided to use a sample of lactic acid bacteria stained with methylene blue. Lactic acid bacteria are accessible and safe. The sample will be visually clear. The bacteria will stain dark blue and will be easily visible against the light blue background. There will be a link in the video description to a detailed guide on how to do this staining. Bacteria are tiny, only a few micrometers in length. Therefore, we will need to use the maximal magnification. The homemade microscope, kids microscope, and stereo microscope will not participate in the competition because you need at least 600 times magnification to see bacteria. As we mentioned, both the student and professional microscopes have lenses that magnify 100 times. These lenses are also marked with oil. The 100 times lens is also marked with oil. This means it needs to be used with special immersion oil. You need to drop the oil directly onto the sample and immerse the lens in it. This way, we can avoid light refraction and distortion, similar to what we see when we put a pencil in a glass of water. An immersion lens is a good thing. It's time to see what we've got. The professional microscope did an excellent job. We can see dark blue lactic acid bacteria, but the student microscope also produced a photo of similar quality. I admit that the student microscope was helped by a special camera. When viewed with the naked eye, the image isn't as bright. But still, a result is a result. We need an even more challenging task. The bee's leg is a large object, and even a silica gel ball could magnify it. Bacteria, on the other hand, are very small. But in some ways, that's good. The microscope doesn't need to focus on a large depth. But what if we take a thick sample of live microorganisms straight from the pond? Which microscope will handle it better? The 10x objective lens of the student microscope did a great job, but the image is too small. I want to see it larger. Let's switch to 40x, no focus. In these cases, adjusting the condenser height, cleaning the objective lens, and adjusting the condenser diaphragm is recommended, but none of this helped me. The problem with the 40x objective is that it has a very short focal length, the distance you need to bring the objective closer to get a clear image. As a user, I don't really want to struggle with finding a technical solution to achieve elusive focus, so I choose the simple way, using a plan achromatic lens with infinity focus. Watch what happens now! And the problem was instantly solved. You can observe the life of diatoms, or see where the amoeba is crawling, or get acquainted with the very flexible ciliate spathidium. After tuning the lenses, the student microscope handled this task very well. It remains to compare how a professional microscope will perform. Now, we observe the microworld through a professional amscope. Here are the diatoms, along with cyanobacteria and green algae. And here is the amoeba crawling, and here swims a single-celled protozoan Euglena viridis. So, which one is a winner? If you place the images side by side, taken with the same objective lens and the same camera, there is still a difference. The professional microscope produces a clearer image due to better lighting and precise mechanics. However, the difference is more qualitative than quantitative. What choice is the best? Here's what I think. If you want to do a fun and quick experiment with students, silica gel beads will do. If you want to leave a child alone with a microscope and have peace of mind, a kid's microscope is better. If you need to examine something not too small and three-dimensional, then a stereo microscope. If you want to seriously study microbiology, then a student microscope. And if you want to grow a YouTube channel and get likes and subscriptions like me, then a professional microscope with plan achromatic lenses with infinite focus and a video camera. All the best and good luck!